So far, we have used terminologies like weather, climate, hydrologic cycle, and so on. We didn't explicitly define Earth system or the climate system. Let's do that here so that we can look at it in terms of the feedbacks that we will understand under climate change, right? So climate system is basically energy being received from the sun, internally being distributed as we saw in warming the surface, creating evaporation, rising air, condensation, moving winds, moving energy from the tropics to the poles, and so on, right? So it's the exchanges of energy and moisture between various spheres. Okay, so we have the hydrosphere, which includes all water, cryosphere, which includes all frozen water, atmosphere, geosphere, and biosphere, and so on. And the processes included are things like human influences, which is about, let's say, deforestation, agriculture, burning forests, burning down forests for various purposes, changing in the amounts of glacier and snow melt, changing the clouds, not intentionally but sometimes intentionally, like seeding the clouds when there are droughts. Israel does a lot of cloud seeding, for example. India has resorted more and more to cloud seeding. China does a lot of cloud seeding. There are also ideas of using cloud seeding to change the energy balance to reduce global warming and so on, which we will see later on. So changes in atmospheric composition. We are not only putting CO2, methane, N2O, and other gases, but also what are called aerosols, as we will see. There is changes in amount of evaporation, precipitation, energy exchange between the atmosphere and the biosphere changes, energy exchange between the ocean and the atmosphere, and so on and so forth. So this is our climate system. Okay, energy coming in from the sun, doing a lot of things internally, and energy being sent back out. The balance has to happen. If there is an imbalance, you begin to warm the climate, which is what we are looking at. Okay, so climate is the long-term atmospheric conditions in a region. I think we already defined it kind of informally before. Weather is what you get. Climate is what you expect. Depending on the season, you think it's going to be warmer, drier, colder, but weather on a particular day can turn out to be unexpected. Earth's climate interactions include the atmosphere, hydrosphere, geosphere, biosphere, and cryosphere. We should also add the anthroposphere to it. In the 1980s, European Union, European countries actually held a meeting to try and define Earth system, and Francis Brotherton actually came up with this diagram. It's much more complicated, but this is a simplified version put out by NASA. He came up with a wiring diagram or a piping diagram for the Earth system. So on the left you have what are called external forcing, so sun's energy coming in, and also volcanoes. Volcanoes are basically taking out stuff that is buried away from the atmosphere and the climate system and spewing it into the atmosphere. Dust, ash, sulfuric acid, CO2, and so on, right? So that changes the energy balance. Anything that changes the energy balance, the radiative balance, radiative forcing, is called external forcing. Human activities are beginning to do the same. So we have put them on the other end, but humans are also beginning to change the radiative balance. So they also in some sense have become an external forcing. Okay, even though they are within the system, they're beginning to change the radiative balance. And then you have atmosphere and its physics and dynamics, chemistry, thermodynamics, tropospheric chemistry. You have the biogeochemical cycles, land use, land change, which are things like deforestation and agriculture, dam building, irrigation, urbanization. There are soil feedbacks involved, CO2 feedbacks involved. Global moisture kind of sits in the middle because it's what is the main mode of picking up energy from somewhere, moving it somewhere, and putting it somewhere else, and creating hurricanes, cyclones, extreme rainfall, and so on. Stratospheric chemistry and dynamics is involved as well. As we said, stratosphere is cooling with global warming because more energy is getting trapped within the troposphere and so on. So that's kind of the brief introduction to the climate system and the Earth system. There is something now called beyond the Brotherton diagram. This is the Brotherton diagram. The beyond Brotherton tend to look at the human decisions, human policies, and their impacts more explicitly. So in the next podcast, I'm going to introduce that beyond the Brotherton diagram. So you can now think that we have become part of this Earth system. We are not anymore like the animals who are obviously also can feedback, but they are responding to climate rather than creating climate change, whereas we are actively modifying the energy balance.